Hello and welcome everyone. I am Shomdeep Laha, Technical Officer 1 at University Science Instrumentation Center, University of North Bengal. This is my second video lecture class of your course, Fundamental Information Technology. In the last class, I discussed what is a computer and what are the different characteristics and basic functioning of a computer are. Today, I will discuss about history and evolution of computer, different generations from first generation to the current generation, block diagram, and different types of computer. Let's begin today's class. If we see the timeline of evolution of computer, Blaise Pascal, a French mathematician and physicist, invented the first mechanical adding machine in 1642. Near about 30 years later, Baron Gottfried invented the first calculator for multiplication. 200 years later, keyboard machine or typing machine were invented in United States. Around the same timeline, Herman Hollerith came up with the concept of punch cards, and these punch cards were used as input media until late 1970s. The first mechanical computer was created in the 19th century by Charles Babbage, and it was called analytical engine. The analytical engine was designed to perform complex computation. In the early 20th century, the first electronic computers were built, and they used vacuum tubes to process data. One of the earliest programmable computer was the Mark I computer, developed by Howard Aiken and his team at Howard University in 1944. You can see the picture of the Mark I computer. It was collaborated with IBM, and it was a massive machine and measuring near about 51 feet in length and weighing over 5 tons. In 1945, Dr. John von Neumann proposed the concept of a storage program computer. As per the concept, the program and data could be stored in the same memory unit. In the 1950s, the invention of the transistor revolutionized computer technology. Transistors are small electronic components that can be used to build circuits, and they made computers smaller, faster, and more reliable. This led to the development of first mainframe computer in 1960s. And these computers are very powerful compared to their timeline and used by large businesses and government agencies. In 70s, we saw the introduction of microprocessor, which allowed computer to be built in a much smaller form factor. Means we are getting much compact from computer. This led to the development of PCs, which were affordable enough for individuals to buy. By the 80s and 90s, PCs became more powerful and more widely spread all over the world and used. This led to the development of internet, which has transformed the way we communicate and access information today. Like I am giving you the video lecture with the help of computer and internet, right? In 2000, mobile computing became popular with the introduction of smartphones and tablets. These devices have become essential tool for communication and productivity. And in recent years, there has been a focus on artificial intelligence, AI, and machine learning. And these technologies have the potential to change industries such as healthcare, finance, transportation, and many more fields. Let's talk about different generation of computer. The term generation means improvement in the development of computer. You can see the first generation computer required near about one complete room to establish a computer system. Every new generation, the circuitry gotten smaller and more advances than the previous generation. So in case of second generation, the room can be replaced with a large table. Okay, so we are getting more compact form of computer. Third generation large table can be replaced with a small table. And fourth generation we are getting much more compact form of computer. And fifth generation we are dealing with laptops. And originally the term generations was used to distinguish between various hardware technologies, but now it has been extended to include both hardware and software. Until today, there are 5 generations of computer. If we see the comparison between different generations, the first generation of computer was based on vacuum tube technology, as I mentioned already, and spanned from 1940 to 56. And electromagnetic relay memory was used, and punch cards are used as secondary storage devices. Example of first generation computers include UNIVAC, ENIAC, EDVAC, etc. IBM 700 series. And the second generation of computer was based on transistor technology and spanned from 1956 to 63. These computers were smaller, faster, and more reliable than the first generation of computer. And example of second generation computers include IBM 7030, 7090 series, UNIVAC Lark, and etc. Third generation of computer was based on IC technology, that is integrated circuit technology, and spanned from 1964 to 71. These computers were even smaller, faster, and more reliable than the second generation computer. And here large magnetic coarse memory were used, large capacity of disk, and magnetic tapes are used as secondary storage devices. Example of third generation computers are IBM 360, 370 series and PDP-8, PDP-11. Those are the example of third generation of computer. The fourth generation of computer was based on microprocessor technology and spanned from 1971 to 80. These computers were even smaller, faster, and powerful than the third generation computer. And here, large capacity hard disk, as in built-in storage device, were used. Example of fourth generation computer are IBM PC and its clones, Apple II, TRS-80, and VAX series, VAX 9000 series. These are the example of fourth generation computer. The fifth generation computer is based on IC with ULSI technology, that is ultra large scale integration technology, and larger capacity main memory were used, optical discs as portable read only storage media, and we are getting notebooks, powerful desktops in this generation, powerful servers, supercomputers we are getting from fifth generation of computer. Commonly known example of fifth generation are IBM notebooks, Pentium PCs, Sun workstation, IBM SP2 series. These are the example of fifth generation of computer. So we can say computers have come a long way since their inception, from the early mechanical computer in 1950s or 40s to the advanced artificial intelligence system of today, and the evolution of computer has been quite remarkable and it is still going. Okay. Now, I want to see these are the electronic devices used in computer in different generation. You can see these are the first generation vacuum tube. The vacuum tube is replaced by transistor in case of second generation computer. These are the third generation where IC is replaced the transistor. These are the fourth generation microprocessor with VLSI technology. And this is the fifth generation where IC with ULSI technology and artificial intelligence are the key component of fifth generation computer. Next, we are going to talk about the block diagram of digital computer. In order to understand how the computer works, it is important to know the different functional unit of a computer system. A computer system consists of mainly three types, that are CPU, most important portion, then input device and output device. The central processing unit, CPU, consists of ALU, which is arithmetic logic unit, and control unit, CU. The set of instruction is presented to the computer in the form of raw data, which is entered through input devices such as keyboard and mouse. After that, this set of instruction is processed with the help of CPU, and the computer system produces an output with the help of output devices like printers and monitors, where we can see our input data, input and process data. A large amount of data is stored in computer memory with the help of primary and secondary storage devices, temporarily or permanently. Volatile memory and non-volatile memory. These are called storage devices. So we can say CPU is the brain of the computer, as without CPU, necessary action taken by the CPU, we cannot get the desired output. So the CPU is responsible for processing and handling all the instruction which is given to the computer system. Now I am going one by one about this unit in details. So this is input unit. The input unit consists of one or more component to the computer like keyboard, mouse, scanner, microphone, web camera, trackball, light pen, joystick. These are nothing but input unit. And these input devices accept the data and instruction from the outside world and convert them into a form that a computer can understand and supply them to the computer system for further processing. Next is storage unit. It holds the data and instruction that are entered through the input unit before they are processed. The storage unit is divided into two categories: primary storage and secondary storage. Primary storage is used to hold the program being currently executed in the computer, the data being received from the input unit, and the intermediate and final result of the program. Okay. Whereas secondary storage is used like an archive. It stores several programs, documents, and databases. And secondary storage devices are cheaper compared to the primary storage devices, and secondary storage devices are non-volatile. They do not require power source. They are capable of store data without power source. Okay, but the primary storage devices are volatile memory, loses data on power, loses data when there is no power. Okay. These are the picture of primary and secondary storage devices. Primary storage devices are ROM and RAM, and here secondary storage devices you can see pen drives, CD, card reader, memory cards, external hard drives. These are nothing but secondary storage devices. Next, I am moving to two important units under CPU, that is ALU and CU. Arithmetic logic unit. First, all calculations are performed in the arithmetic logic unit of the computer. It can perform basic operations such as addition, subtraction, multiplication, division, and logic operations such as greater than, less than, and equal to, etc. Whenever calculations are required, the control unit transfers the data from the storage unit to the arithmetic logic unit. Right. Once the computations are done, the results are transferred back to the storage unit by the control unit and then sent to the output unit for displaying result. Next is control unit. It controls all other units in the computer. It instructs the input unit where to store the data after receiving it from the user. It controls the flow of data and instruction from the storage unit to ALU, and also the flow of results from ALU to the storage unit. So we can say control unit, we can compare control unit to the central nervous system of the computer, which control and synchronizes its working. Next is central processing unit. And the control unit and arithmetic logic unit (CU and LU) of the computer are together known as central processing unit. And CU performs all the calculations, takes all the decision and control all the unit of the computer. And you can see under CPU there is arithmetic logic unit (ALU) and CU, and they are connected to main memory with different buses. Next is output unit. These are the commonly known output unit of computer: monitor, where we can see our data or input; speaker, plotter, projector, printer, and headphone. And the output devices accepts the result produced by the computer, which are encoded from and hence cannot be easily understood by us because it is machine language. It converts those machine language to human acceptable form and supplies the converted result to the outside world. And there is also another important output device is projector. Uh, Moving to the next slide, computers can be broadly classified based on their speed and computing power. We have PCs, workstation, mini computer, mainframe, supercomputers. These are the different types of computer we have today. So what is a PC? PC is small, relatively inexpensive computer designed for individual user, and they're based on microprocessor technology. And PC are mostly used in home, offices, educational sector, for personal computing, entertainment purpose, education purpose, gaming. Businesses uses personal computer for word processing, accounting, desktop publishing, and for running spreadsheet, database management. Various applications of PC we have today. And next is workstation. Workstation is also a single user computer system that is similar to the personal computer but has a more powerful microprocessor. Workstations are typically used for high-end applications such as graphic designing, video editing, and scientific simulations. Next is mini computer. This mini computer is a special type of computer that was popular from 1960s to 80s. It was a mid-range computer that was smaller and less powerful than the mainframe computer, but larger and more powerful than the personal computer. Mini computers were used in a variety of applications such as scientific research, industrial process control, and data processing. The common example of mini computer are DEC PDP-8, PDP-11, HAX series, and IBM systems. But the rise of microcomputers and the decrease in the cost of computing power led to decline mini computers. Next is mainframe computer. A mainframe computer is a special type of large-scale, high-performance computer that is designed for processing vast amount of data and performing complex computation. Mainframes are typically used in enterprise-level organizations such as government agencies and large corporations for critical applications that require significant computing power such as financial transactions, data processing, and scientific computations. Next, we have supercomputer. A supercomputer is an advanced and high-performance computer system and which is designed to process and manage complex application and large volume of data at a very high speed. Supercomputers are capable of performing massive calculations and simulations that are beyond the capabilities or capacities of normal computers. They are used in various fields such as scientific research, weather forecasting, medical imaging, engineering, and defense. Supercomputers are often made up of thousands of interconnected processors that work together to execute complex tasks in parallel processing, enabling them to process massive amount of data and perform calculations at incredible speed. To establish supercomputer in any building, we require special arrangement, and we need cooling system to cool them down. So this is all about today's session, and thank you for watching, and I hope you find this video lecture informative and useful. And I will discuss about different types of input devices in details in our next class. So thank you once again. See you in our next class.